Hello and welcome to this new lesson in which we are going to discuss assignment operators. Assignment operators are used to assign different values using different operators. Some of the operators we already talked in previous types of operators. The first one is the assign operator. It's a very straightforward one. It's basically the equal sign, and here we are assigning the value of 20 to the variable x. Here we have and assign, the plus equal sign. This can be interpreted to x equals x plus 3. What this will do is add 3 to x value and assign the final result to x. So in this case, if x equals 10, which is the previous value of x, 10 plus 3 equals 13, and these 13 will be stored inside x as the new value. We usually use the plus equal 3 to short this equation into onto this shape. Now same thing goes for all of these equations. X minus equal 4 is basically x equals x minus 4. And if x is 10, then 10 minus 4 is 6. So the value of 6, which is the result of this, will be stored inside x. So x value will be updated and become 6. Now going here, x equals x multiplied by 5. X equal, or the original value of x is 10. 10 multiplied by 5 equals 50. So x will equal 50. This will be the new value of x. If we went down here to the last one, x equals x divided by 2. So 10 divided by 2 is 5, and 5 will be stored inside x. So the new value of x will be 5. This is the short form of this equation. This is the short form of this equation, and this is the short form of this equation. Now, we also have the same thing for the bitwise operators and or not, and we have it for the mod or the percentage sign operator. Now x and equal 1, it means x equals x and 1. And since we are dealing, when we are using AND or XOR, we are dealing with x as a binary number. It will equal 0, 1, 0, 1. And we want to add 1 with this. It will be 1 here. So the final result will be 1, 1, 0, 1. So 3 plus 10 equals 13. So the final result will be 13. Now, the same thing goes for the OR and XOR. X equals X or 15. X equals X, the XOR sign 2. You need to convert 15 to the binary form. So 0, 1, 0, 1, and 15 equals 1, 1, 1, 1. This is x, the original value, which is 10, and this is 15. Now the final value, you have to OR them, or 0 and 1 equals 1, 1, 1, 1. So the final value will be 15 as well. So x will equal 15. And we already mentioned how to do this in the bitwise operators lesson. Now the XOR is the same case. You need to add the value of x, which is the original value, equals 10, and 2 is 0, 1, 0, 0. Now we already mentioned that if they are identical, the result will be 0. And here the result will be 0, here the result will be 0, here it will be 1. So the final result for x will be 8. So x equals 8 as a final result. This is the result of the XOR operation. You can use the calculator to make sure of these numbers, or you can watch the lesson that we will add to the end of this course that is called numbering systems, in case if you are interested to learn how to convert binary into decimal without using the calculator. Now, the last equation here is x equals x mod or percentage 4. Now we already know that x value is 10, and we mentioned that you need to divide it by 4. So 10 divided by 4 equals 2. Now 2 multiplied by 4 equals 8. 10 minus 8, 10 which is the original value, minus 8 which is the result of the multiplication, will equal the remainder, which is 2. So the answer here will be 2. X will equal 2. And I just showed you how to calculate it. First, you need to turn this into a normal division. 10 divided by 4, it will equal 2 without fractions. When using division, there are no fractions. Now, to know the remainder, we need to multiply the result without fraction by the division factor, which is 4. The result will be 8. And then we subtract the original value, which is 10, for x, minus 8, which is this value. The result will be the remainder, which is 2. X equals 2. Now, the last two assignment operators are the shift right and shift left. Now, when we write it like that, x shift right by 1, we are applying right shift to x by 1 and assigning the value to x. So it's like writing x equals x right shift by 1. Same thing here, x equals x left shift by 1 without using the equal sign. And this is a very important thing to know, as you can see. So in this lesson, we learned the assign, the add and assign, plus equal, minus equal, multiply, divide, and, or, XOR, and the modulus. We also learned the right shift and left shift. Now, let's do a quick practical implementation for these values to see the result. Now, first we need to include the library as usual. Then void main void. Change the language to C. And let's define x equals 10. Now let's call this assignment operators. Now, we already mentioned that we need to try all of the assignment operators that we just mentioned. The first one is x equals 10. We just tried it, the assign. Then we have x plus equal 5, x minus equal 3, x multiplication equal 5, x division equal 2, and we have the and, x and equal, let's say 1, x or equal 1, x or equal 1, and we also have x right shift by 1, x left shift by 1, and we have the mod sign, x mod equal 2. Now, we already mentioned that we must reinitialize x after each of these operations. This is something you must do to make sure that you are getting the right results. So let's do this here as well. Okay, we are done. Now let's remove this from here and print the values. So printf let's add %d and x. Now here I will add the equation, but let's first copy this. I'm just doing this so that we can see the final results for each of these operations. That's it. Now we just need to copy these equations inside the double quotations. Okay, we are done. That's it. We just need to add this equation here as well, plus equal. Now let's try running this program. Now GCC, let's zoom in. 9 assign operator.c a.exe, and here we have the results. Now 10 plus equal 5 equals 15, 10 minus equal 3 equals 7, 10 multiplied by 5 equals 50, 10 divided by 2 equals 5, x equal 2, I think this is the percentage sign. Okay, now to get it right, we already mentioned that you need to write it twice. Let's clear the screen, compile again, and run. Now x mod 2 equals 0. Since it's 10 divided by 2, there are no remainder. Now x and equal 1 equals 0. X or equal 1 equals 11. You can check it out yourself. X or 1 equals 11. X right shifted by 1 equals 10. And x left shifted by 1 equals 10. Now, all of the results are correct except for the last two, the right shift and left shift operators. Now, in some compilers, x shift left by 1 and right shift by 1 are not recognized unless you add the assignment operator, which is the equal sign. So to fix this, you need to go back to your code and write x equal and x equal. Now this will solve the issue in the GCC compiler. Other compilers will execute it as it is and show you the right result. Now let's compile again, see again. Now as you can see in here, x shift left to the right was 10 in both cases, which is the wrong value. Now here, x right shifted and left shifted, here it equals 5, here it equals 20, which is the right value since we added the assignment operator. Now, these are all of the assignment operators that you need to know. If you have any question about any of them or you failed to implement any of them, we are here to help. Thanks for watching this lesson. This is Ashraf from Educational Engineering Team.